Okay, so here we go. Question number 1 in 8.4. So now we're basically done with confidence intervals. We've done confidence intervals for proportions, for means, and then sample size. This is the end of the chapter. Next time we're going on to hypothesis test. So we're going to keep doing confidence intervals for the whole course, though. We'll just do them for fancier and fancier things. Now they're going to ask us concept questions. These are pretty much all true and false. And so it's going after, so this can be kind of the hardest in a lot of ways. It's going after, do we really get what a confidence interval is? Remember, let's talk about, remember how we first went over well, let's just read the question. That'll probably be best. 200 Americans were asked how far in miles they currently live from their place of birth. How far do you live from where you were born right now? That's what they're asking. 10 minutes? No. A 95% confidence interval was computed as 80,300. What does that mean? So this is really the most important part, because probably in the rest of your life, after this class is over, most of you will never compute a confidence interval again. I know it's a shock. I know you were thinking, this is my pattern for life now, Mr. Herring. No, probably not. Like most of your college classes, you'll take a little bit and not much from it. But the one thing I do, as I think about the fact that I am a small part of your college experience, and I do want to enrich you in what you will use, and that is you'll read studies. Almost every one of you at some point, I would say probably all of you, will read something like this in any professional job. And will you understand what it's really saying? That's the purpose of this class, really, is to make you a good understander of statistical information. As I said in the first day, it's all about that. So what does that mean? What does that mean? A 95% confidence was computed as 80,300. Yeah, exactly. Good. So between 80 and 300 miles, what about between 80 and 300 miles?
They're 90% confident that's where the average is.
Yeah, good. Well said. We're 90% confident, 90% sure. 95. 95. 95% confident that the average of what? Average of who? Average of the 200 Americans? Is that what it is?
No.
It's important that you know that's not what it is. That's really important. Remember what we're doing in statistics. Don't lose the forest for the trees. Let's step back and remember, what are we even doing here? What is statistics all about? It's about grabbing a sample of 10, 50, 200, finding their average, and letting the average of that 200 inform you about what might be the average for all Americans. That's what we're talking about. We're saying we're 95% confident that the average for all Americans. Because that's what we really want to know. We don't just want to know about those 200 people. I don't even know those 200 people. I don't really care how far those 200 people live from where they were born. Like I said, I don't even know them. Who cares about those 200 people? But I'm wanting what we got from those 200 people to tell me something about what the whole nation is doing. That is kind of interesting to me. How far do people live from where they were born on average in America? I'd kind of like to know that. It's not going to stay up all night worrying about what the answer is, but yeah, it's worth 2 seconds of my time. If somebody knows that fact, I'd be kind of interested in how far people move from where they were born on average in America. Now, we don't got time to ask everybody in America. That study would cost millions of dollars. We don't got time for that. So instead, what they do is they ask 200 people, and they hope that average is similar to the average for all America. Well, how do they hope? Well, that's exactly what all this statistics is about, is how sure is our hope. That's all probability and on you go. Well, it turns out we're 95% sure. Never 100%, but pretty sure, 95% sure that the real average, the true average for all Americans, is somewhere between 80 and 300 miles from where they were born. They now live. So remember, that's what they're going to, if you get that, that's what all these questions are going to, they're going to ask you one way or the other on every one of these questions to see. They're going to ask it this way and ask it that way and ask it from the top and ask from the, to test if you really are getting that concept. That we're taking a sample and the average of the sample informs some true average. I think that's why I think election day is such a perfect example, because the truth comes out in November every 4 years, right? They do all these polls about how much they think candidate A and candidate B are going to get in the vote. And they keep guessing and guessing and guessing by asking different groups of people, 200 people, 500 people, whatever. And then November, the real truth comes out, and we see how accurate or inaccurate their estimates were. That's exactly what we're always doing in statistics. So here, what's their actual question then? So they're setting this up. They go blah, 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 blah. Then they say, then they're going to ask us what that means. With 95% confidence, it's going to be true or false, it can be said that the average distance all Americans, I guess, live from their place of birth is between 80 and 300 miles. Is that what they're saying? Yeah, that sounds good to me. That's exactly right. That makes sense? 95% confidence can be said that the average distance all Americans live from their place of birth is between 80 and 300. Good? Shall we try another one? Well, number 2 is already up there. Look at number 2. A 95% confidence interval for the mean was computed with a sample size 90 to be 16,22. Then the error is plus or minus 3. Is that true? How do we determine this? So they're saying they've got this confidence interval 1622. It's a 95% confidence interval. The sample size, the size of the sample was 90. I'm just taking the things they said here. 95%, 1622. Is the error plus or minus 3? What do you think? Is the error plus or minus 3? Anybody know how we determine that? Could we find the middle of this interval? How would we find the middle? Add and divide by 2. Remember, that's how you find the average and middle of anything. So add them and divide by 2. Right? Divide by 2. I think you'll get 19. So 19 is the middle of 16 and 22, right? So how far is 19 back to 16 and forward to 22? 3. Yes, that's the error amount. Has nothing to do with the size or the confidence level. It just has to do with how wide the interval. Remember, the error is the amount from the middle up or down, isn't it? So yeah, the error is plus or minus 3. That's another true one. We good there? Is that making sense? A quicker way is you could just look at this interval. How far is it from 16 to 22? If you subtract them, it's 6. The error's got to be half that because it covers half the distance each way. Yeah, so the error's got to be plus or minus 3, doesn't it? That good? Try number 3. So giving you another confidence interval and asking you about the error on that one. Is that one, so they're saying 1014, the error is plus or minus 2. Is that true? Yeah, that's the same thing, because that's a gap of 4, which is plus or minus 2 either way. Perfect. All right, number 4. A researcher computed a 90% confidence interval for the proportion of students who smoke. If the researcher had instead used a 95% confidence interval, then the computed margin of error would have been smaller. Ooh, is that true? Margin of error is smaller when the confidence interval goes up. Is that true or is that false? So remember, think about real life. Think about like if you remember. I started off by talking to you about the average on the exam, and I said maybe the average is going to be, I don't know, the average is going to be 70, or in the retake, didn't I say? I think the average will be 80%. But, it's not exactly give or take 10% error, right? And I said, I think I'm 90% confident that on exam 2, the retake, the average is going to be 80%, give or take 10% error, so from 70 to 90. But then if I want to be more sure, if I want to, you know what, I'd like to be more sure of my estimate of the average on the exam. So I'm going to say I'm 95% sure that the average on the exam is going to be 80%, give or take. So what would I need to do with the error number if I wanted to be more sure? Make it bigger, like 20%. I want to give myself more margin, huh? Yeah. Right? So when the confidence level goes up, the error has to go up. That just makes sense. Is that what they said? Yeah. Oh, yeah. Oh, no, they said smaller. Yeah, they said when it goes up to 95, the error should get small. The margin should get smaller. That's false, isn't it? Yeah. Yeah. The margin should get bigger. That make sense? On that good? Feel like you can recreate this kind of thinking for yourself in the middle of an exam with the clock ticking away? You can write that example right in your sheet. Probably too many examples to write them all, I guess. Is that good? Is that making sense then? If you want to be more sure, you got to take a wider interval. There's more error room if you want to be more sure. Right? You got to give yourself more leeway if you want to be more confident. Number 5, increasing the sample size and decreasing the level of confidence are two ways of obtaining a narrower margin of error for a confidence interval. Not true? These aren't easy, are they? Even though they're just true-false. Let's think about that. Okay, what is our goal here? The goal is a narrower margin of error. In other words, less error. Like I want to estimate, I want to predict what you guys are going to get on exam number 3, let's say. I want to predict. I think, I'm 90% confident that on exam 3, your average score is going to be 80%, give or take 10%. Let me just start with that same number. And then I say, okay, now I want to make a more narrow statement. In other words, if I say 80%, give or take 10, that's going all the way from 70 to 90, isn't it? That's a pretty broad statement. I'm not saying much. I'm just saying anywhere from a C to an A will be the average. That's not a very informative statement, is it? But if I want to narrow that and say, look, all right, okay, I think your average, make a more narrow statement here. I think your average is going to be 80. I still think 80, is my best guess. But I'm going to give or take only 5% now, which takes me only from 75 to 85. I'm saying you're either going to get a high C or a low B average. Now I'm saying something a little more specific. So think what it takes to make a more narrow statement like that. Would increasing the sample size help that? Yeah, right? Talking to more people makes you more sure, right? If a sample gets bigger and bigger, if they're polling and they only say, I asked my 3 friends who they're going to vote for, and so I'm 90% sure that the average of all America is, you talk to your 3 friends, really? That's your polling method? It'd be better if they at least talk to 100 people at their school, or 200 people at the mall, or 500 people at some event, right? That'd be better. The more people in the sample increases accuracy, which makes you able to make a more narrow, precise statement. So yeah, that's good. And how about decreasing the level of confidence? Would that also make a more, if they say, well, I'm only 80% sure. Would my confidence level go down when I want to make a more narrow statement? Yeah, that's right, isn't it? Right? If I wanted to say 80, give or take 10, I could be real sure of that. That's all the way from 70 to 90. But if I want to say, no, I'm going to make a more narrow statement from 75 to 85, I'm going to be less sure I'm going to get that right, aren't I? I'm going to be less sure that the real average comes out in that zone. So lowering your confidence level or increasing your sample size, they are right, true. Those are two ways to make a more narrow, precise statement. How we doing? Do you like these? These are a little slippery, aren't they? All right, let's move on to number 6. Feel free to stop me if you want to talk about these. How about number 6? If the sample size is increased and the standard deviation and confidence level stay the same, then the margin of error will also be increased. So basically, if sample size goes up, does that mean error goes up? That's what they're saying, right? Everything else stays the same, they said. Sample size goes up, that'll make error go up. Is that true? Or is that false? Yeah, that's the opposite. More in your sample makes less error, makes you more precise, huh? So that's completely false. That's the opposite of the truth. Sample size up means error down, doesn't it? Makes a more narrow statement. We getting that? We good? It's making sense? More in your sample makes you able to make a more. That's why they do bigger samples, right? So they can make a more precise statement with less margin of error. If the level of confidence is increased from 90% to 95%, then the margin of error will be increased. Yeah, it is true, isn't it? Because again, if that's, it looks like most are comfortable. Let me say it again. To help, just think about like estimating the average for the next exam. If I say I think I'm 90% sure that the average on the next exam is 80%, give or take 10. That's 90% confident. If I want to be more confident, 95. If I want to be more sure that I really get the true average in my interval, am I going to say 80% plus or minus a smaller amount? No, I'm going to say a bigger, huh? I'm going to say 80, the error amount is going to go up because that gives me more room, right? That lets me go from 80 minus 20 to 80 plus 20. That's from 60 to 100. I'm pretty confident the average is going to be somewhere from 60 to 100. I can say that with 95% confidence for sure. See how more confidence comes with more error margin. Just gives you more room. Right? So yeah, so that's true. Number 8. Let's move on. All right, what do we think? Number 8. A sample size. 42 college students produced a 95% confidence interval for the mean number of coats owned. How many coats do you own? Then there is a 95% chance that these 42 students own an average between 3.1 and 5.2 coats. Let me let you read.